GATE 2021 question 5. One of the following vector functions represents a magnetic field. So we are given four options here. So first, in order to determine which of the following vector functions is giving a magnetic field, we first need to understand that divergence of a magnetic field is always zero. Why it is so? It is established by demonstrating it with the help of a diagram. If this is a magnet and if we draw the magnetic field lines, we know magnetic field lines emanate from north and come back to south, completing a loop, and inside the magnet it will be south to north, so it completes a full loop. Now if you see, if you take a closed surface like this, magnetic fields are emanating from the surface and coming back. Similarly, magnetic fields, you see, are emanating from the surface and then coming back. So net inward or outward flux due to a magnetic field equal to 0 implies divergence, that is the tendency of the field to diverge in or out from a closed surface is 0. So now we come to the solution. We know divergence formula is given by d dx of x hat plus d dy of y hat plus d dz of z hat, and we need to take the dot product of it with the magnetic field vector. Now d dx of x hat plus d dy of y hat plus d dz of z hat, and if the magnetic field vector is a x hat plus b y hat plus c z hat, then d dx of a plus d dy of b plus d dz of c is the answer. We know the dot product of x and x is 1 and x and y is 0. Because dot product of like terms are 1 and dot product of unlike terms are 0, because x hat, y hat, z hat are separated by 90 degree, and dot product means the cos of the angle between those two vectors, which if unlike will make a 90 degree and cos of 90 degree is 0, and if like they will make 0 degree, so cos of 0 degree is 1. So dot product of like terms are 1, so only these terms will be available, like terms dot products. So now by seeing the option, we only need to take the derivative of the magnetic field vector x component with respect to x, the derivative of the magnetic field vector y component with respect to y, and the derivative of the magnetic field vector z component with respect to z. So just seeing the option, we can tell that the option will be this, because you see derivative of 10x plus derivative of 20y minus derivative of 30z, or you can write plus and minus here, will be 0, because 10 plus 20 minus 30 is 0. So option A is the answer. Option A will be the answer. Thank you.